Welcome to our modern, unified, and integrated data analytics platform. In today's video, we'll explore the core objective of Job Workflow 2 and how it enhances your data processing capabilities. The primary goal of Job Workflow 2 is to develop and run Python jobs within the data science lab and seamlessly integrate them into a pipeline. This workflow is designed to streamline and automate your data processing tasks. In Workflow 2, this job entails reading files from the sandbox, applying transformations using DataPrep, creating and executing a notebook in DS Lab, and integrating it into the pipeline for automated processing and monitoring. Let's get started the live demo of BDB Platform. Our journey begins at the login page. Here, you'll input your credentials to access the platform. Enter your username and password, then click the Sign In button to proceed. Once logged in, we'll navigate to the home page of the platform. The BDB Platform's home screen is the central hub where users effortlessly access their assigned files, reports, and dashboards. It's the starting point for easy navigation and quick access to your content. The Platform app menu is a key component of the home screen. It has all the plugins available within the platform. Each plugin plays a crucial role in executing different use cases and enables the platform to deliver complex functionalities. Choose the Data Center plugin. This will take you to the Data Center page, where you can manage your data. Navigate to the sandbox where you've already uploaded the hiring data file. We'll show you how to use DataPrep to clean your data using the hiring data file you've already uploaded in Workflow 1 and the sandbox you've created. Select Data Preparation icon for hiring dataset. We'll navigate to the Data Preparation homepage. Here on the Data Preparation homepage, you can see your complete dataset displayed in a grid form. The Data Preparation plugin automatically profiles the data, providing valuable insights into its characteristics and detecting any anomaly data. You can also view the data profiling details. On the right-hand side, you'll find the selected columns profile. Here you can explore various details such as charts, information, and patterns associated with the selected column. All the transformations will appear inside Transform tab. Let's walk through the process of adding a transformation to data. Here we have AutoPrep Transform, which helps us clean the complete dataset. This includes removing special characters, handling missing values, and normalizing data. Once it's done, save preparation and close it. This is how we prepare, and we can reuse it for many different data engineering tasks and modules. Before creating the Python job, the user has to create a project in the Data Science Lab module under Python environment. Now let's select the Data Science Lab plugin from the app menu. With the BDB Data Science Lab, you can unleash your creativity by creating AI and ML models. Choose to create a new project or select an existing one that you've already configured. Here needs to use Python TensorFlow environment. Once selected, activate the project. Next, select Repo, and then click on the Create option. Specify notebook name and provide a brief description. Once done, click Save to create your TensorFlow notebook. And that's it. You've successfully created a TensorFlow notebook in the BDB Data Science Lab. Let's add a dataset. Click on the data icon and select the Add icon. A Choose Data Sandbox file from data sources to list all available files. Select the hiring data from the list to add it to your notebook. Once added, the dataset conveniently appears in the data section of your notebook. Select First Cell. Click on the first cell in your notebook. Bring dataset into Notebook. Select the dataset of interest, such as hiring data, to populate the code in the notebook cell. Run the code. Execute the code in the cell to load the selected dataset into the notebook for analysis. Let's add predefined preparation. Choose Data Preparation from the context menu. Select the specific preparation you want to apply. Here are the transformations we've done in this preparation. Generate the preparation script. Modify the data frame name in the script as needed. Execute the cell containing the modified script to apply the transformations and get the transformed data. Next, define a function named loadData in another cell. Paste the data preparation code, DataPrep code, inside this function. This Python script allows you to write any necessary code. And at last ensure the function returns the prepared data frame. Test the function. Now let's test the function. Print the function loadData, execute the cell to test it. This step verifies that the function successfully prepares and returns the data frame. Successfully prepares and returns the data frame. Next step is save and register the notebook as a job. Save the notebook. Click on the Save button to save the notebook. Register the notebook as a job. Go to the repository where your notebook is located. Right-click on Context menu and select the Register option. Here we have to choose the function you want to register and click Next. Validate the function details and click Next. On the Register as a Job page, enter a scheduler name as Words Python job. Select the Start function. Let's select a resource allocation option for our Python job. You have 3 choices: low, medium, and high. Select the appropriate option using the radio button. Next, provide the resources required to run the Python job in the Limit and Request sections. In the Limit section, enter the maximum CPU and memory required for the Python job. In the Request section, enter the CPU and memory required for the job at the start. Specify the number of instances needed for the Python job. To create an on-demand job, check the On-Demand option. We will cover on-demand jobs in more detail in the next video. Alert. There are 2 options for sending an alert: success and failure. Select success to send an alert to the selected channel upon successful execution of the job. Specify the webhook URL and choose channels like Teams and Slack. Select failure to send an alert to the selected channel if the job fails. Specify the webhook URL and choose the desired channel. Click Save to register the job. Once saved, the job will be created in the pipeline jobs and activated for execution. We can check in pipeline module where job is getting executed. Next, let's move to the pipeline to view and manage our job. Choose the pipeline plugin from the app menu and select the list of job icons. Here, you can view the job registered from the Data Science Lab. Select the job to check its logs and monitor its execution status. Once it's completed, we'll get the success message and logs. Let's start by understanding the job you've scheduled. This job has been set with a default time interval of 1 minute and a forbid concurrency policy, ensuring that only one instance of the job runs at a time. Click on the View button to check the job's configuration. Here, you'll be able to see the settings that were applied when the job was registered. Confirm that the job interval is indeed set to 1 minute as intended. Now let's move to log verification. Navigate to the logs to ensure that the job is being scheduled and executed at the 1 minute interval. Look for timestamps to confirm that the job triggers as expected and adheres to the schedule. Thank you for exploring Job Workflow 2 with us. We hope this guide helps you effectively develop, run, and integrate your Python jobs within our modern, unified, and integrated data analytics platform.